So yeah. So there are multiple examples that are currently available on the web and that are really working towards customer to save customer time and really helping them in recommending or selecting some of the products. Let's move on to the data acquisition or the techniques that we generally use when we try to think of a recommended system for implementation. The first thing is the data, that what type of data is with us and how we are going to recommend something from the data. So the first type of data that I can talk is explicit data, which is customer rating can be one of the data that is explicitly available in the system. Feedback. Feedback can be thought of in two ways, like likes and dislikes, which is a very binary type of feedback. Or it can be textual feedback, which is really hard to use as feature. But if you really wanted to use the textual feedback, you really need to structure that feedback. Generally, a normal feedback is unstructured. Demographics. Demographics can be statistical data of the user, maybe age, gender, employment status, and the location. Psychographics. Psychographics is one of the examples that we saw on wantful.com, that we are trying to see the personality of the person or the attitude, the interest, or the lifestyle. Maybe asking the question, as they said, do you like to cook, or what do you do in your free time? So this is the type of psychographic data that we generally ask from the user. Purchase history. Ephemeral needs is also one of the explicit data. Ephemeral needs is a need for the moment. You might need something that is explicitly you need for that very particular time. Implicit purchase history or the browse history, we are calling this as implicit because the guest doesn't know that someone is capturing that data for me for recommendation or some other purpose. And then another thing can be product information, product taxonomy, product attributes, descriptions, or even the knowledge base that is existing in your system. Let's directly jump to the recommendation generation techniques. First and the most popular technique in the world is collaborative filtering. Here what we do is we try to find a set of users who has very similar interests than our target user. And then we try to recommend the products from the set of that we found as a collaborative users, the users that have a similar interest set. So as we say, this is a method to find a subset of the users who have similar tastes and preferences from the target user, for which we are generating the recommendation, and then using this subset for offering recommendations. So you can see the example that is available there. Customers who bought this item. So in this one, I had selected, I think it was Nikon, some DSLR camera, and then it suggested the compatible lenses with it and some UV filter protection. So customer who bought this also bought this. This is a type of collaborative filtering technique example. So when we talk about collaborative filtering, the basic assumptions that we take is that the user with a similar interest have common preferences. Let's say guest A or user A and user B are adventurous in nature. Then if the guest B or any collaborative set of adventurous people liked or did, let's say paragliding or skydiving, then it means that our target user, which is user A, will also like it, and we will recommend that paragliding or skydiving to him. And the second assumption is there should be a sufficiently large number of user preferences available in the system for which we are going to build this recommendation system. Otherwise, we won't be able to create the collaborative user set. Okay. So moving on to, again, how the general or the basic algorithm works. We select a target group, target user who is requesting the recommendation, and then we create the set of collaborative users. So how do we do it? We can do similarity metrics to find the collaborative users for this target users. That can be an offline process, and there are different algorithms available, or the two mathematical formulas available, like Euclidean distance or cosine similarity calculation, or maybe Pearson correlation coefficient. There are multiple ways there you can calculate the similarity between two users. And then you can offer the recommendation of the products as liked by collaborative users or as used by collaborative users. A simple prediction function that is shown here is, let us say we want to calculate the prediction for user A for an item J. We will try to find the similarity of all the collaborative users. So number K is a set number of collaborative users, and sim AI is a collaborative user set for similarity with this user for the target user with the collaborative set user, and we are multiplying it with the rating difference for any item J, for the item J for that particular rating by the user and the average rating of the collaborative user. We will sum that up and multiply this with a modulation factor and add it up with the average rating of our target user, which will give us the prediction function or the prediction rating for any particular item. Let's take another example of the collaborative filtering algorithm. This is a little bit different than what we saw earlier. This is called as item-to-item collaborative filtering algorithm rather than user-to-user. So what we are doing here, let us say there is a customer who purchased a product, let's say I1, and let's say it's a camera, and he also purchased another product, I2. We will try to get the similarity between the product I1 and I2, and then we will offline create the pairs of each product, and then we will see if any customer purchases, if that customer purchases any other product other than I1 and I2, we will see what are the similar distance products. Let's say here we find the similarity as X. So we will try to see for each product what are the other products that are at distance X, and we will try to suggest those products as recommendations. This is the algorithm that Amazon.com uses. Moving on to the problems that we generally face with collaborative filtering is a cold start. Cold start is the problem that we already discussed, that we need enough users in the system. It was a basic assumption initially made that we have ample set of users so that we can collaborative sets for each target user. Sparsity is another problem because when we make clusters or the groups, we really find there are a lot of spaces, empty spaces in between, where where it is really hard to recommend anything to the guests. First rater is another problem where we can say we cannot recommend anything because it has never been rated. It's a new entry in the system, or it can be a product which is only specific to certain users. Our popularity bias. We tend to recommend a product which is very frequently rated or very frequently used. So we tend to over-recommend that product. So there is a less room for unique people with a unique interest. So there are different examples of collaborative filtering recommender systems. Ringo is one of them. Ringo is a music recommender system that used to tell you all the artists that you can enjoy. It can also use to predict what are the albums or the artists that you will hate, or you can also see the personalized reviews from the people with a similar taste. Ringo became Firefly, and later it was bought by Microsoft. GroupLens is another research group that has created multiple recommender systems. TechLens is one of that, where you can find recommendations on technical articles. There's another one, Movie Lens, which is again created by GroupLens. You can find the recommendations for the movies. Let's move on to the second type of recommendation generation technique. That's the content-based systems. Here we recommend only those products or the products that are similar to the products that user has purchased in the past or liked in the past. That's one. Or We can also say recommendations are based on the information of the content rather than other users' opinion. So we create user profiles to describe the type of the items that user might like. So we can say that we have a user profile who likes sci-fi, action, comedy, and then we will try to match these features of the user profile with the features of the product. Okay. Keyword-based search is also a type of content-based system. There is an example of Letizia, which was an extension of the browser. What it does is it tracks the user behavior when user is visiting the website, and then it tries to create a strategy, keyword-based strategy, and then directs you, which should or make a recommendation to you or multiple recommendations that what should be the other sites that you might like. IMDb is one of the content-based systems where it tells you or recommends you on the basis of genres you generally like in movies. Last of them, there's a tool called Scrobbler, which also helps you with the music recommendation, but how it does is you install it on your machine, and then it learns that what are the music that you're listening on your computer, and then on the basis of genre and the artist, it tries to recommend you some new songs or the new albums and artists. So there are some advantages over collaborative filtering when we talk about content-based system. Because we don't need other users' opinion, so we don't need data for other users. So there's no cold start or sparsity problem here. And we can also recommend data to the unique people with a unique taste, because if we have the user profile of a unique person, we also, if we have a similar product, we can directly match it and show it to the user. And then we can recommend any new item or a very unpopular item, so there is no frustrator problem that we saw initially in collaborative filtering. And the last one that I really like is that you can provide explanations for the recommendations, that why we have recommended this product to you. I have seen a lot of times in Amazon also that why recommended. If you click over it, it hovers a modal and it tells you, okay, because you selected, or let's talk in terms of a movie, let's say you hover over a movie and you say that why you recommended me this movie, I can say, okay, because you liked comedy, romance, and action, or this movie has all these genres or features in it, so that's why I have recommended it. So what it does generally is increases the trust of the users in the recommendation system, in the recommended system. So we need that so that more and more people use our recommended system and think it as a genuine system who is really interested in recommending good quality stuff to you. But there are some limitations in content-based system. The basic one is data should be in structured format. We should be having all the metadata associated, all the features properly listed. If you have a music site, it was a challenge initially for some of the music sites that if you cannot read the content of the file, if we talk about music or a video, all you have to do is you have to label all the files with the proper genre, artists, albums, and all the features that you can input, so that you can really filter the feature as per the user's need. And another limitation is in your system there might be very quality judgments of the ratings by other users, but you cannot use it because it's designed like that. The next technique that I would like to talk here is data mining. Data mining is very vast, so out of all the different techniques like association rule mining or classification or clustering, I have just picked association rule mining and clustering for today's discussion. So association rule mining is really focuses on finding the rules, and then we will predict the occurrence of the item on the basis of how other items were present in the transactions. To really understand the data mining part, I would like to introduce few terms before I can talk how this works. So K items, let's say I is our inventory where we have multiple items from I1 to IM, and then we have a subset X with K items in it. So that subset with the K items in it can be called as a K item set. Then we have a support. For any transaction, we call support is the probability of that transaction occurring. Let us assume here X is bread and Y is butter, to be very simple. What is the probability that when a guest or a user buys bread, he also buys butter? Okay, so this is called support. So probability of occurring of both the transactions together, or seeing both the items together in a transaction. The second term that I would like to introduce here is confidence. So confidence is a conditional probability of Y occurring, giving the condition that X is also occurring. So which is the probability of X and Y occurring together over the probability of only X, all the X's that occurred in the transaction set. Okay, so then we calculate the frequent item sets. So for frequent item sets, we first define a minimum support. We know that support is the probability of having X and Y together in a transaction. So we define it. When I say we, it means that admin defines it maybe as a 50%. My 50% of the transactions in the transaction set should have support equal to 50%. If that is happening, then all those K item sets we will call that as frequent item sets. Given all these facts, this is the process how we use association rule mining. We will find all the frequent item sets. How we do that? If you directly jump onto the last part of the slide, there is a Rody algorithm, which works on the principle that if there is an item set that is frequent, all the subsets will be frequent. Then what we do with the frequent item set, we generate all the rules from those frequent sets that we discovered, and then we reduce the set of rules to the ones that are meeting minimum user specified confidence. Again, as we initially defined the support, here we are also again defining the confidence. What is the minimum confidence that we would like to have in a transaction set? Then we can say, okay, this is what we can recommend. Okay, giving an example of a system that works on ARM is a Surflen. Actually, Surflen is a system that works on mining the navigation history of the recommendation. And what it does is it tracks the user behavior on the web and uses the association rules to extract the hidden relationship between the navigation history. The relationship can be between the URLs that are read together by the users, and the relationship can be between the set of the users who read the same set of web pages. So here we are seeing in the first part of the example, the relationship between the URLs that are read together is a pure ARM type of example. But the second part, where relationship between the set of users who read the same type of web pages, it's more of a collaborative. So here we are seeing, in the second example, we are seeing a concept which is also called as hybrid recommender systems. So hybrid recommender systems where we use multiple techniques. Maybe some part of the recommender system is using content based and some part is maybe collaborative. The other one of the topics that I want to discuss from data mining is clustering. So clustering is making groups of like similar items. So how we calculate the similarity, as I told initially, that we can have Euclidean, there are multiple distance metrics that we can use to find clustering, to find the similarity between two groups. And after finding the similarities, we will try to create groups where intra-cluster differences are minimal and the inter-cluster differences are maximum. So there are different algorithms that are available in the market or in the research area that can help you do the clustering. One is partition algorithm, other one is hierarchical. There are others also, but these are the two majors. So partition divides into non-overlapping clusters with exactly each data item in exactly only one cluster. Hierarchical algorithm successfully cluster items within hierarchy. So you kind of produce nested clusters. An example is a Google News that also use clustering for logically grouping the news rather than showing you the raw listing of the news. So it used the cluster mechanism. Then the next one that I would like to discuss is constraint-based recommender system. This is the type of the recommender system that we are currently working on for one of our cruise liner. So here, what do we do is we request the data from the guest first. So we get all the customer requirements with item features, maybe in term explicitly or maybe implicitly asking them maybe what are your interests, and then we can map those interests with our products that we have internally in the database. And then our recommender system has already knowledge bases, means products, and then we have a mapping for those products with the interest or the explicit or implicit inputs that we get from the customer. So there are two major types of variables that generally plays a role in a constraint-based recommender system. One is customer properties, like let's say I'm requesting the interest, what is your time and budget, means for how long you want to go or when you want to go for your vacation. From where you want to depart is also one of the important questions that I can ask. You are in what is your geographical location? You want to depart from India, or you are in some other location of the world. And accommodation and activities preference. What type of accommodation you need? You need a very basic accommodation, or you need a very luxurious accommodation. And activities preference. You want to do something when you go there, or you just want to do sightseeing and you do stuff on your own. So these are the questions that I get generally asked from the customer in constraint based. And then we have product properties also, destination dates, ships. So these are the properties that all the products that we have internally in the knowledge-based system. So I can say, let's say I want to go to Alaska. Alaska is my destination, and what are the dates when my cruise or anything that goes to Alaska? So it should not be winter, because nothing happens in winter in Alaska. So all the dates will be in summer. Then what are the ships that are going to there? Then what are the ports of call? What are the activities that are offered on the ports of call, or even on the ship, because the ship also offers you a number of activities. Then constraints. What are the constraints that are already there in the ship that we say that these are not compatible things? We can say a person might want a very luxurious accommodation, and that is not available in certain ships. So if I can say that if the ship if the accommodation is luxurious, then this ship should not be ABC, the ship name. Or maybe if a person says, I want to do some adventurous activities or relaxing activities, and these type of activities are not available on certain port, then I would say, okay, no, this is a constraint in the system that I should take care of. Then we will create some filter conditions that, okay, if the customer input is weekend vacation, then I cannot consider any vacation which is greater than 10 days, or even a shorter duration vacation preference cannot be, we cannot recommend any longer vacation. Or lower budget is incompatible with the suites on the ships, because suites in the ship can cost you up to $17,000 for 7 days per person. So these are the incompatible filter conditions. Then after applying all these conditions, we are left with the products that we can really suggest with the users. And what we are doing currently in our system is we are doing a weighted constraints. We are not saying clearly that this is a no or this is a yes for recommendation. We weight them. Then after weighting, we get the highest weightage for the products. And initially, how we are getting the destinations from the initially when customer gives us inputs like interest, maybe psychographic or the demographics input from his choice, we create a vectors out of that and map it to the available destinations, and then we add up those to create weights for the system, and then we create sort them to give the final recommendation, maybe top 3 recommendations or top 3 vacations for the guest. These were the techniques that are available, or the most popular techniques that are available for recommender systems. One of the tools that I want to discuss here is it's a very young tool. The name is Apache Mahout. This is capable of executing complex data and data mining algorithms, and also collaborative filtering. It currently works. It's supported on Hadoop, Apache Hadoop, which is a distributed large dataset system. But it can also support single node, smaller systems, or even a non-Hadoop clustered systems. The features that generally Hadoop offers is, Mahout offers is collaborative filtering, and that we saw, content-based recommendations, data mining algorithms, clustering, and classification. All these are generally, and this is currently this Apache Mahout don't have any kind of interface, but it's a Java-based library that you can call and use to make recommendations. Moving on to our next topic of the session is design. What are the factors that impact the design? The first one is the data model, because this is the main thing, as I initially talked, that you must be having some data set that you can think of how you are going to generate recommendations out of it. Is your data unstructured, or your data is structured or partial? So if data is unstructured, you might have to make some efforts to make it structured so that you can make some recommendation, or you can do even clustering on it so that you can get the similarities on certain features, right? So because in both the type of systems, even if it is a collaborative or it is a content-based, you have to create the similarities between the two types of entities. The second one that you should take care of is user profile. Who are the users and what are their preferences? Are they just customers who are just buying, or there are people who are just seeking the news or technical? Because based on your user profile, you can also think of the utility of the recommender system. Is it going to impact your revenues or not? And then algorithms. Which algorithm or the method you should use? Depending upon the structured or unstructured data or type of the users, if you have a lot of user data in your system, then obviously you can go for a collaborative set of user algorithms. If you don't have user type of user data, but you have a product data and you can exploit that data for recommendation, and definitely you have another set of algorithms to use. What tools to use? You want to use a custom code or a specific tool, like the different tools that are available in the market. What is the architecture? How it will be implemented? What are the touch points, external points? How you will be interacting and integrating with the existing system? Because your recommender system is a subset of the complete system. So it has to interact, get the data, existing data, and it has to even post that data to an existing, because you're not going to make a new site for your recommendation area. So for your recommendation, you might be just showing the recommendation in an existing area. So you have to kind of think that which technology suits best as per the current architecture of the